Okay, this is 10-6. The title of this section is Circle, Circumference, and Arcs. The first half of these notes is going to be somewhat review. In fact, me and the math group were talking the other day, and we might actually next year move this section to the circles unit, the polygon unit, or the two-dimensional unit that we had before this. Because I had to touch on some of this stuff during that unit anyway. So part of this is going to be review. The reason why it's a part of Chapter 6 or Chapter 10 in the book is because of the circumference and arc length that we're going to talk about in here kind of leads into the area that you're going to see in the next section. Remember, this unit technically is on area, not length or circumference, but this is going to lead into that, which is why we're going to study it now. Okay, so keep in mind the first part of this is going to be a review, but it's okay. It's not going to hurt for you to see it twice. Alright, so vocab, again, stuff you already know, but that's okay. Curved portion of a circle measured in degrees. When we talk about the measurement of an arc, okay, here's where some of the terminology is going to be really important. Okay, this stuff you've already seen. Okay, it'll say like M arc AB, and that means they want the measurement of the arc. Okay, when they're talking about that, they're talking about that degree, and it's going to be the same as the central angle that forms the arc. Okay, so if I have a circle, remember this is the center of the circle, so that's called a central angle. If this is 37 degrees, then the measurement of arc AB would also be 37 degrees. Okay. Like I said, I know that seems kind of simple, but when we go talk about arc length later on, it's going to be really important that you understand that this means that angle measurement. Okay, so if you like to color code your notes, I'm just going to go ahead and box that for vocab. And remember, this angle and the measurement of the arc are the same. Okay, naming an arc. I talked about this a little bit right before the test from the previous unit, because if you're going to try to find the measurement of an arc, you do have to know how to name them. There are two types of arc. There's a minor arc and a major arc. So they are named different ways. And so if I have that circle and I have these arcs, a minor arc, again, is less than 180. Again, this is old vocab. But I didn't really talk that much about it last unit about how do we name this arc. You use two letters. Okay, so for instance, DC with an arc over the top would be this arc right there, because it's a minor arc. It's less than 180 degrees. A major arc is bigger than 180, You're going to use 3 letters. So an example of that would be B, D, A. And this arc B, I did see 1 or 2 people on the test, and some of you had to correct it when you corrected your test or retook it. When you marked this arc, you didn't realize it was an arc. Okay, an arc goes along the outside of a circle. So I had some people going D and then across the circle to D and then over to A. This is not an angle. If you see that arc symbol, or if it says arc before it, they are talking about, and back up here, the curved portion of the circle. It's on the outside. It does not go to the middle. So D, B, A. Here's my D. I have to go to B before I can get to A. I can't go this direction. It has to be in this order. So from D, all the way over to B, past B, all the way over to A. That's what this arc says. Okay. And then a semicircle. Again, a lot of this is old vocab. This equals 180. You still use 3 letters. Okay, because how do you know which semicircle I'm talking about? If I say semicircle AC, how do you know if I'm talking about the top portion or the bottom portion? Okay, so an example would be A, B, C. That arc would be talking about from here through B and over to C. Okay, so it's all about the order of the letters. Another vocab. Okay, that's an old vocab word. Move it up. Okay, adjacent arcs. You know what adjacent angles are, so hopefully you can transfer that knowledge over to arcs. Just means next to. Okay, so an example of this would be, 2 adjacent arcs would be BC and DC would be adjacent. Notice they do not overlap. Okay, so those 2 would be that arc and that arc. They don't overlap, they share a point. Okay? Alright, so again, like I said, that part should all be pretty much review. Now let's do some examples that are new. Let's talk about length and proportions of a circle. Okay? So now that we have these central angles and these arcs, and it divides the circle up, how can you use this? Well, pie charts are a very common tool used in the real world to represent information, to represent data. You can use your knowledge of circles to help navigate around these pie charts. So let's say you're trying to create a pie chart. You have data, okay, and you need to know what angle to make that section of the pie chart. Okay, you want your pie chart to be correct. You want it to be proportional. You want it to look right. Okay, so let's say you have data. Okay, let's say your data says 52% of something. This could be types of food you eat or something. Color of hair, I don't know. 20% have some other kind of trait. 18% and 10%. Let's say this is the data you've collected and you want to create a pie chart. Let's just take one of these. Okay, let's just take this one. If we need to know how big of a wedge of the circle that should be, so we need to find the central angle. So on this one we're going to find the central angle. Okay, what you need to realize say this is 18%, is that circles are always proportional. Okay, when they are divided into these sections, everything, the angle, the central angle, the arcs, the length of the arc, the area of the arc, the degree of the arc. Everything about it is going to be proportional to the total circle. Okay, so if I'm making a proportion out of this, I know that 18% can be written as a proportion. 18% can be written as 18 over 100. So this is the proportion. This is the part here, and then we have a total circle. So 18, so this part is orange, and the entire circle represents purple. So we're talking about the whole circle. And we have that represents the whole circle, and this represents just the part of it. Now we can set that equal to the angle, because remember I said everything's proportional. That means if you set up ratios, they should all equal. So I don't know what this angle is. I don't know theta. But I do know an angle that represents the entire circle. That would be 360. So the theta represents the part that I want, and 360 represents the total circle. And now I can cross multiply and solve. So 18 times 360 equals 100 times theta. I didn't grab a calculator today. Oh, I must have done this last year. Hold on. Should give you 648. 100 times theta, and then to solve for theta, you just divide by 100. So theta equals 64.8. Okay, so if you were trying to draw this pie chart, okay, whether either by hand or on a computer software, you could tell the computer to make that part 64.8 degrees, and then that way your pie chart would be perfectly drawn to scale for your data. Okay, all right, let's look at another example. All right. Let's say this angle is 128 degrees, and we want to find the measurement of arc BC. Okay, this example is going to be review because we're talking about arc measurement again, which we've already talked about in the last unit. Okay, so we're looking for BC. So BC is this arc all the way to there. Oh, I forgot to put one thing in the picture. This is a 90-degree angle. Okay. Well, in order to find this arc, we need this total angle, which means we can find these two angles and add them together. So, how do you find measurement of arc BC? Well, you know that this is a diameter. DD is a semicircle. That means it's 180 degrees. So 180 minus 120 equal to 60. Oh, that's 128, not 120. Sorry. 128 is 52. Okay. And then we also need this arc. Okay. Well, if this is 90 degrees and that's also a semicircle, then the other one has to be 90 degrees. So the total arc for BC is going to be equal to 52 plus 90, which is 142. Not too bad. Again, that part's for you. Alright, we're getting built up to the final thing. Last thing you need to do to know how to do is circumference. The formula for circumference is either 2 pi r or d pi. Okay. So if I gave you a circle and I asked for circumference and I told you the radius was 6, I would use this formula because I was given radius. If you're given diameter, you could use this formula. So c equals 2 pi times 6. And I could leave this as 12 pi. This is called leaving it in terms of pi. All you do is treat pi like it's a variable, like it's an x, and you just leave it alone. Okay, this way you don't have to round any of your answers. Of course, if we're doing this on the clicker, you would have to get into a decimal form so that you could click it in. Okay. The pi button on the calculator is Control, and then it's the book button. It's the button that has the book on it, and it gives you the pi button. Okay. Alright, so that's pretty easy. Alright, this is the last example. I got 4 minutes left to stay underneath my 20-minute mark. Okay, this is the one where you'll be doing most of your work in the book on, because this is the new stuff. This is the main learning goal of this section, is this example right here. Okay, you have to be able to find arc length. Okay, this is the main thing of this entire section. Okay, and it uses concepts from all the previous examples that we've just done. Okay, remember, circles are proportional. Okay, that's the concept that we're going to use for this. So, if I have a circle, and that is the center, and I want the length of AB. And here's where I said that terminology is going to be important. Okay, if it says M of AB, that doesn't mean they're wanting the length. That means they're wanting the angle. If they want length, they will literally say length of AB. So don't use this formula unless they're actually asking for length. Okay, that's a big thing people get confused on. So AB is this length right here. So what they're saying is if you put a string on this and actually stretch it out straight, what would that length be? Okay, we're going to use proportions because we can make a ratio out of the central angle. And then we can make a ratio out of the length, the circumference, right? And we can set them equal. Okay, our ratio should be the arc on top and the total circle on bottom. So, central angle. The central angle for this arc, okay, is, oh, I forgot one important part of the picture. This arc is 60 degrees. Okay. So, to find the measurement of AB, okay, I would do 180 minus 60, which is 120. And I'm going to put that over the total circle. Remember, we're still on angles. 360. Okay. Now I'm going to do length. On the top would be just the arc, so we would have length of the arc. And on the bottom we would have the length all the way around the circle. We have a word for that. It's called circumference. Okay? That is the formula for circumference. So this right here is your formula for every single one of these problems. It's the angle ratio is equal to the length ratio. Okay, so let's go ahead and plug into our formula. So the measurement of the arc is 120 over 360 equals, we're trying to find the length of the arc, and we're going to put it over 2 pi, in this case the radius is 12, because we divide that by 2. Okay. And to solve for this, we would just take this and multiply. So, times 2 pi 12 times 2 pi 12, and that cancels. We're left with the length of AB is equal to, how is that pen running out already? Equal to all of this multiplied together, which gives me 25.13. Okay, so here's your formula. Highlight it, put a big star by it, and you will plug into this formula and solve for your variable every single time on those length problems. Okay?